Hello, class ninth. So, we have been studying chapter number 8. So, motion. So, last time we studied about the speed, distance, displacement. So, before we start the chapter, let's revise whatever we studied in previous class. Yes. So, as you know that what is motion? Motion is actually change in position of an object with respect to time, yes, or you can say change in position of the body with respect to time. Okay, whenever the motion happen, position changes. Okay, and you know that there are two type of motion, uniform motion and non-uniform motion. Yes, uniform motion and non-uniform motion. So uniform motion is that motion in which speed does not change. In uniform motion, speed does not change. Means uniform motion is can be described as the equal distance traveled in equal interval of time. Yes, if the speed is changing, speed is not constant, then you can say it is non-uniform motion. Yes, so we can say that the unequal distance traveled in equal interval of time is known as non-uniform motion. Okay, if or you can say the unequal distance traveled in unequal interval. So in non-uniform motion, distance and time both can be unequal, or one should be equal, either distance or time. Okay, and we also studied that there are different types of motion. Yes, there are different type of motion, random motion, transitional motion, rotational motion, oscillatory motion. Okay, there are four type of motion, RTO, random motion, R for random motion, R for rotational motion, and T for transitional motion, and O for oscillatory motion. And transitional motion can be divided into three category: RCC, R for rectilinear motion, C for curvilinear motion, and circular motion. Okay, and what is distance? Distance is the total path of the length, actual path of the length traveled by the body, actual length of the path. Okay, and displacement, if we talk about the displacement is the shortest length of the path traveled by a body from initial position to the final position. Yes, and we also studied about speed, that speed is defined as the total distance per unit time. Yes, speed of a body is the total distance traveled in unit time. Okay, so the formula of speed is distance upon time, and distance is denoted by s, time is denoted by t, speed is denoted by v. So we can write v is equal to s upon t. V means speed, s means distance, upon t means time. So this speed is equal to distance upon the time. If we talk about the average speed is actually the ratio of the total distance traveled in total line length. Yes, and what is the SI unit of speed? Meter per second. Yes, and what is the SI unit of distance? Meter. And the displacement SI unit is also meter. Okay, now kids, let's talk about speed with direction. Means let's talk about the velocity, because speed is scalar quantity. Yes, speed is scalar quantity, so it has no direction. But if speed is with direction, then we will say it is velocity. Yes, so the rate of motion of a body is more meaningful if we specify its direction. Yes, if we have given direction, then it is more meaningful. Yeah, but speed has no direction. Okay, so the quantity which specify both the direction, motion, and speed is velocity. So velocity is vector quantity which has mm, both direction with magnitude. So what is velocity? Velocity is a rate of change in speed, you can say, or you can say that velocity of a body is the displacement of the body per unit time. Yes, velocity is defined as the displacement of the body per unit time. Yes, displacement of the body per unit time means displacement is happening because displacement has direction. When displacement is changing, it means it is velocity, or you can say rate of change in velocity. If the speed change with time, then it is velocity. So since velocity has both magnitude and direction, so it is a vector quantity. So the formula for velocity is equal to distance upon time. Okay, velocity is equal to distance upon time. And what is the SI unit of velocity? Well, the SI unit of velocity in speed is same. The SI unit of velocity is also meter per second. Okay, but actually velocity is actually the rate of change in speed. Change in speed means whenever we are talking about the speed, here will be two position of velocity, initial velocity and final velocity. So we can say that average velocity, if we talk about the average velocity is the ratio of total displacement to the total time taken. Yes, total displacement to the total time taken. Okay, and average velocity is also mean of the initial velocity and final velocity. Yes, so we can say the average velocity is actually the means of initial velocity and final velocity. So if you have given initial velocity and final velocity, then you can easily calculate average velocity. Okay, so the formula of average velocity is initial velocity plus final velocity upon 2, means u plus v upon 2, u plus v upon 2. Okay, so speed and velocity have the same units, meter per second or meter per second inverse. Okay, or meter second inverse. So it was all about velocity. Remember kids, what is velocity? Velocity is actually the velocity of a body is the displacement of the body per unit time. Yes, displacement upon time. This is the formula for velocity. Okay, and since the velocity has both magnitude and direction, so it is vector quantity. Okay, I hope you understood about speed with direction. Now let's talk if the velocity is changing, means rate of change of velocity. Okay, now we studied about the velocity is rate of change in speed, but if velocity is changing, means rate of change of velocity, then what do we will call it? Let's move on the next point. Okay kids, so let's study about acceleration. Acceleration, the spelling of acceleration is A-double-C-E-L-E-R-A-T-I-O-N, A-double-C-E-L-E-R-A-T-I-O-N, acceleration. So you know, during uniform motion actually speed does not change. Yes, but if the speed is changing, then it is non-uniform motion. And so during uniform motion of a body in a straight line, the velocity remains constant. Yes, during uniform motion of a body in a straight line, the velocity remain constant with time. In this case, change in velocity at time, any time interval is zero, means there will be no change in velocity because the motion is in a straight line, uniform motion. But in non-uniform motion, the velocity changes with time. The velocity changes with time. Means in this case, the change in velocity at any time interval is not zero. Yes, it may be positive or negative. Yes. So the quantity which specify the changes in velocity is acceleration. Yes. So what is acceleration? Acceleration is actually the rate of change of velocity. Yes, rate of change means time. We are talking in with respect to time. So acceleration is change in velocity of body per unit time, or you can say rate of change of velocity. Yes. So in if velocity is changing, Then velocity is changing means motion is non-uniform. Motion is non-uniform. There must be a direction. Okay. Then acceleration produce. When velocity changes, acceleration produce. When velocity changes, acceleration produce. Maybe the may be possible that speed is constant, but if direction is changing, then you can say it's a velocity is producing, and when velocity is produced, acceleration will produce. Yes. So the formula of acceleration is change in velocity upon time. You know acceleration. We use the word accelerator. We use the word accelerator when we drive the car. You should put the leg on your foot on your accelerator to decrease the speed, to increase the speed. Yes, that is the work. Accelerator means increasing or decreasing. So velocity is changing. Suppose if the velocity of a body changes from initial velocity u to the final velocity v in t time, then what will be the acceleration? Yes. So if the initial value is u and final is v, then acceleration will be final velocity minus initial velocity upon time taken, means a is equal to v minus u upon t. So if we talk about the unit of acceleration, what is the unit of acceleration? Because the formula of acceleration is change in velocity upon time, and we know that formula of velocity is meter per second, and time is also given, so meter per second square. Okay, so the SI unit of acceleration is meter per second square, or you can say meter second inverse. So that's all about acceleration. Okay, so acceleration also can be uniform and non-uniform. Yes, acceleration can be uniform or non-uniform, but direction always changes. Direction should be included, whether it is uniform or non-uniform. So what is uniform acceleration? If the change in velocity is equal in equal interval of time, it is known as uniform acceleration. Yes, if the velocity that changing in equal interval of time, if the equal velocity changing in equal interval of time, it is known as uniform acceleration. And what is non-uniform acceleration? If the change in velocity is unequal in equal interval of time, it is known as non-uniform motion. Yes, if the change in velocity is unequal in equal intervals of time, it is known as non-uniform acceleration. Okay, so I hope you understood that during acceleration velocity must change, and with respect to time. So time and velocity both can be equal or unequal, but if velocity is equal with respect to time, it doesn't mean that speed is not changing. It means speed is changing. Yes. So whenever the acceleration produce, the acceleration can be decrease or increase. Okay. So remember what is acceleration is the change in velocity of a body per unit time, or you can say the rate of change of velocity. Yes, velocity is changing with respect to time, so we can say the formula of acceleration is change in velocity upon time, means acceleration is denoted by a, and velocity is denoted by v and u. Initial velocity is denoted by u, final velocity is denoted by v. Sometime initial velocity can also be 0, sometime final velocity can also be 0. So the formula is a is equal to v minus u upon t. I hope you understood about rate of change in velocity. Now let's talk about the graph, distance time graph. Let's move on the next point. Okay, now let's talk about the graphical representation of motion. Now we will represent the motion in the form of graph. So we will study the different type of graph. First graph is Distance time graph. So if a body is moving with in uniform motion, if a body is moving in a uniform motion, means it is traveling equal distance in equal interval of time, then the graph will always be straight line. Yes, so as you can see in the picture, the graph is in a straight line. Yes, so whenever we show the graph, whenever we represent the graph, on x-axis we will represent time value. Yes, and on y-axis we will represent distance in meter. Time in second, distance is always in meter. Okay, so you can take any 2 point of the straight line graph a and b. Suppose you have 2 point a and b, and a is the point where any body reaches in t1 time and travel s1 distance, and b is any point where the body reaches in t2 time and travel s2 distance. So we can show as you can see in the picture. So the change in position of a body, the change in position of a body with time can be represented on the distance time graph. Yes, the change in position of a body. Yes, if the position of a body is changing, means the body is traveling a distance. Okay, in this graph, distance is taken on y-axis and time is taken on x-axis. So the distance time graph for uniform motion. Yes, this graph is actually for uniform motion. So the distance time graph for uniform motion is a straight line graph. Yes, or you can say linear. Okay, this is because in uniform speed a body travel equal distance in equal interval of time. Yes, because as we already know what is uniform motion. In uniform motion equal distance is equal interval of time. So the body will travel equal distance in equal interval of time. So, or you can imagine, you can imagine that a car is moving. A car is moving in 5 seconds. Suppose a car is moving, if in 5 seconds it reaches 10 meter. Okay, it completes the 10 meter distance, and within next 5 minutes it reaches, it again travel 10 meter distance, means in 10 second it travel 20 meter. Then next 5 second, means in 15 second it travel the again 10 meter distance, means 30 meter distance. So what is happening? The time interval is same: 5, 10, 15, 20, 20 minus 15, 5, 15 minus 10, 5, 10 minus 5, 5. And the distance is also same: 0, 10, 30, 0, 10, 20, 30, 40, 10 minus 0, 10, 20 minus 10, 10, 30 minus 20, 10. So what, the distance and time both are same. The distance and time both are so we can determine the speed of the body from the distance time graph. Yes, we can easily determine the speed of the body. Okay, and we know that the formula of speed is distance upon time. We know the formula of the speed is distance upon time, means v is equal to s upon t. V is equal to s upon t. So the time frame will give us the value of speed. The time frame will give us the value of speed. So here we will take AC T2 T1, AC T2 T1. So as you can see, AC T2 T1, here we can see that speed is we have to, as at A point is S1 and at B point is S2. So we will take S2 minus S1. Yes, the change in speed, and total time T2 minus T1. So we will get the value, and in this way we will get the value. We will put the value in the place of S2 we will write 20, in the place of S1 we write 10, in the place of T2 we will write 10, in the place of T1 we will write 5. 20 minus 10 equal to 10, 10 minus 5 5, 10 divided by 5 we will get value 2 meter per second, which is actually the value of speed. So in this way we can calculate the speed. Okay, so for the speed of the body between the point A and B, between the point A and B, where the distance is S2 minus S1, time is T2 minus T1, then we'll get 2 meters second. So in this way we can calculate easily the value for distance time graph. Okay, so I hope it's very easy, it's not difficult. Now let's talk about the non-uniform speed graph. Okay, let's move on the next point. Okay, it is also, this is also a distance time graph. This is also time distance time, but it is for non-uniform motion. Means when the speed is changing continuously. So whenever the speed changes, the graph cannot be straight line graph. Yes, whenever the speed is changing, the graph cannot be straight line graph. It will always be the curve like graph. Yes, it is non-linear graph. Yes, so the distance time graph for non-uniform motion is non-linear. This is because is a non-uniform speed. It means a body is traveling unequal distance in equal interval of time. Yes, body is traveling unequal distance in equal interval of time. So as you can see in the graph is a curve like structure. Yes, so there is different speed in the graph. On x-axis time is represented, and on y-axis distance is represented in meter. So 0, 5, 10, 15, 20, 0, 20, 10, 20, 30, 40. So kids, you can imagine, just imagine that you are riding bicycle. Suppose you are riding bicycle. So within 5 seconds your car reaches 1 meter. Yes, suppose, sorry, your bicycle, within 5 seconds your car reaches 1 meter, and in next 5 second means total 10 second. So in next 5 second your car reaches 9 meter per second, 9 meter. Okay, and in next 5 minutes means 15 minutes, total 15 minutes, your car reaches to 17 meter, and in next 5 second your car reaches to 29 meter. So what is this? The time interval is same, means the time interval is 0 to 5, 5 to 10, 10 to 15, 15 to 20. So the interval is same, but the traveling distance is different. Yes, in first 5 seconds you travel only 1 meter, then in next 5 seconds you travel 9 meter, means the difference of 8, and next 5 seconds you travel 17 meter, means the difference of again 8, but in next 5 seconds you travel 29, means the difference of 11, I think. So you are traveling unequal distance but in equal interval of time. So this kind of motion is known as non-uniform motion, and this kind of graph is for the distance time graph, in which so distance time graph for, I hope you understood that distance time graph for uniform motion will always be a linear graph. Yes, straight line graph, but the distance time graph for non-uniform motion will be non-linear, means it cannot be straight line graph. So I hope you understood. Now let's move on the next point. Okay, its next topic is equation of motion by graphical method. Yes, so there are three equation of motion. Well, uh, I am showing you today only equation of motion. We will talk in detail about these equation of motion. So by graph method, we will get these three equation. There are three equation of motion we will get by the graphical method. Today we studied only one graph, distance time graph. Okay. In next class, we will discuss velocity time graph and different graph through which we will get the value of these equation of motion. Okay, so there are three equation of motion. First is v is equal to u plus at. Okay, second is s is equal to ut plus half at square. Third is 2as is equal to v square minus u square. So the motion of a body moving with uniform acceleration can be described with the help of three equations called equation of motion. Yes, the motion of the body moving with uniform acceleration. Yes, suppose a body is moving. Suppose a body is moving with uniform acceleration. Uniform acceleration. Okay. Then we can describe with the help of three equation called equation of motion. If a body is moving with uniform acceleration, these three equation are: first equation, v is equal to u plus at. V is equal to u plus at. V means final velocity, u means initial velocity, a means acceleration, t means time, and s means the distance traveled or position, you can say. First equation is v is equal to u plus at. Second equation is s is equal to ut plus half at square. Third is 2as is equal to v square minus u square. Maybe you cannot see clearly, but don't worry. I will show you again these equation. Okay. Now it's time to ask question from you. Let's move on the last point. Okay, it's time to ask question. Question number 1. Show the distance time graph for uniform motion and non-uniform motion. So as you know that the distance time graph for uniform motion will always be straight line graph. Yes, this is because in uniform speed a body travels equal distance in equal interval of time, and the graph for non-uniform motion will be non-linear curve like. This is because non-uniform speed a body travels an equal distance in equal interval of time. Yes. Next question. Question number 2. Write the three equation of motion. Yes, there are three equation of motion. First equation, v is equal to u plus at. Yes. Second is s is equal to ut plus half at square. Third is 2as is equal to v square minus u square. These are three equations. First is v is equal to u plus at. Second is s is equal to ut plus half at square. Third is 2as is equal to v square minus u square, where v means final velocity, u means initial velocity, a means acceleration, t means time, s distance traveled or position. Question number 3. Define velocity and acceleration. Write their formula with SI unit. Yes. So what is velocity? Velocity of a body is actually the displacement in the body per unit time. Yes. So since velocity has both magnitude and direction, so it is a vector quantity. And the formula of velocity is the formula of velocity is displacement upon time. And if we talk about the average velocity is the ratio of the total displacement to the total time taken. Yes. So or you can say that average velocity is also mean the initial velocity and final velocity. Yes, means initial average velocity is equal to initial velocity plus final velocity upon 2. So the unit is SI unit of velocity is meter per second or meter second inverse. And if we talk about the acceleration, what is acceleration? Acceleration is actually the change in velocity of a body per unit time. Yes, or you can say acceleration is actually the rate of change of velocity. Okay, so the formula of acceleration is equal to change in velocity upon time. Suppose if the velocity of body changes from initial velocity u to final value v in time t, then the formula of acceleration is change in velocity upon time, means a is equal to v minus u upon t. If we talk about the SI unit, there are two unit of acceleration. The unit of SI is meter per second square, or you can say meter second inverse. Okay, so there are two type of acceleration: uniform acceleration and non-uniform acceleration. What is uniform acceleration? If the change in velocity is equal in equal interval of time, then it is uniform. And if the change in velocity is unequal in equal interval of time, then it is non-uniform. I hope you understood. Now we will meet in next class. We will study velocity time graph. Till then, bye bye.